Okay, thank you very much. Okay, so my name is Kentaro Kitamura, professor of the Marine Satellite Enterprises and In-Orbit Experiment, Kyushu Institute of Technology. So today's my talk is about a brief introduction on the importance of space weather research with CubeSat. So prior to the following three presentations. So I would like to first introduce the purpose of this session and why the space weather research is important at CubeSat mission. Okay, so, sorry. As you already know, the space weather refers to the electromagnetic environment in space, often caused by the solar activities. These space weather phenomena are known to have an adverse effect on social infrastructure, often including the spacecraft failures. So therefore, at the human sphere, the human activities expand into the outer space. The space weather research is becoming increasingly important. So, by the way, so I think there are actually two aspects to space weather research. So one is as a practical science, and the other is as a fundamental science. So as a practical science, we need to know about the relationship, the space weather to the satellite charging, single event upset, sometimes ratchet, and ionospheric disturbances sometimes causes the GNSS error expansion and blackout. Also, during the geomagnetic storms, the geomagnetically induced currents is flowing in the long power grid lines and causes sometimes the power grid blackout. And also recently, the spacecraft exposure, radiation effect on the avionics is recognized as one of the risks of the space weather. Okay, so to avoid these problems, accurate forecast of space weather is an important objective of space weather research as a practical science. Okay, so another important aspect is space weather research as a fundamental science. Such a study has been conducted by many researchers in the field of solar terrestrial physics, even before the concept of space weather was created. In order to build a more accurate space weather forecast model, more comprehensive understanding of the physical coupling from the sun to the Earth is required. So to understand the space weather as a nature science, so it is essentially important to clarify these three things. So one is to understand the energy transportation from the sun to the Earth's atmosphere. Related to first, the second one is the electromagnetic coupling among the sun, solar wind, and the magnetosphere, ionosphere. This coupling is very important. So, and also the behavior of the plasma particles coupled with many waves. So actually there are so many energy range of the plasma is in the magnetosphere. So one of the important objectives of this solar terrestrial physics is acceleration process of these plasma particles. So recently, the acceleration regarding to the acceleration of the plasma particles, the plasma wave in the magnetosphere play a very important role is recognized recently. So in order to improve the space weather forecast, so we need to understand these things comprehensively. So regarding to the satellite observations, the many satellite observations have been conducted in space weather research. The main physical quantities of importance in satellite in situ observation are plasma particles and electrons at various energy ranges. And electric field measurement and magnetic field measurement in the various frequency is very important. So here is an example of the Arase satellite launched by JAXA in 2017. The satellite was launched with the goal of elucidating the wave particle interaction in the plasma environment in radiation belt. So actually, one of the speakers today, Professor Shinohara, is a project manager of this satellite. So our satellite is equipped with the 9 instruments, 9 different type of instruments to closely measure the plasma behavior and electromagnetic waves in a magnetosphere. So you can see the list of the instruments here. So we often refer to this satellite as a full spec satellite. This one is many kind of measurement instrument installed in one satellite. So in order to achieve the important science results, so it is better to have many instruments on board as possible to make a wide range of observations. So what are the advantage of using CubeSat and nanosatellite for such observations? So it may seem almost impossible to conduct this kind of observation using the CubeSat. But so I want to note, so it is important to note that even if many kinds of instruments can be on board, so there are important limitations for the single point satellite observations. So I'm showing here a schematic figure. So suppose now that a satellite observed such kind of magnetic field variations. So, however, we cannot distinguish whether we are observing a spatial distribution due to the satellite movement or whether the entire region is changing over time. So we cannot distinguish essentially. So this one is the disadvantage of the satellite in situ observations. So to compensate these limitations, coordination between the satellite observation and ground-based multi-point observation is extremely important in the space weather research. So I'm showing the 2 examples of the ground multi-point observation. So one is the geomagnetic observation conducted by the Kyushu University. So they have more than 50 ground stations to observe the geomagnetic field. So it can derive the spatial and temporal variation of the ionospheric current pattern. So and also, so next one is the total electron contents observation by using the many ground or GPS stations. So conducted by the NICT. So this can derive the ionospheric plasma disturbances using the many ground stations. So you can see the perturbation. This can be propagation of the gravity wave in the ionosphere. So at the northeast of Japan earthquake occurred in 2011, from Tohoku area, the wave is expanding. So you can see here. So, disadvantage of the ground observation is the measurement of indirect physical quantities requires inference through the assumption and the models. So the complementarity between the satellite and ground-based observation has been conducted in the very conventional study styles. So, but now I think the CubeSat constellation, if the CubeSat constellation for these observations, we can done. So it can be changed the CubeSat constellations. So this one is the very important point of the space weather research by using the CubeSat. So today, I asked the three speakers to introduce each space weather observation mission. So Yotsuba Clover is but each mission have a different physical. Each of three missions aims to measure a different physical quantity, and missions are carried out with different approaches. So Yotsuba Clover is the use of quartz magnetometer for geomagnetic observations. And the BARS 5 is a miniaturization of the high-energy electron measuring instrument used in the conventional satellite observation. And also the Kitsune spatial mission with a new approach to ionospheric TEC observation using the characteristics of the CubeSat. Okay, so sorry, I don't prepare the summary slide, so that's all my presentation. Thank you very much.
Okay.